Alright, welcome to our lesson today on factoring polynomials. This one is going to be an absolute doozy. Hopefully it's not super long, but there is a lot to cover. Alright, so the goals for today is to factor polynomials using common factors, so using what we learned with greatest common factors. And then we can also factor polynomials using the guess and check or the criss-cross method or decomposition. Alright, so let's go over the common factors method first. Alright, so now let's go over common factors. We have a question down here to factor 4m plus 12. So what we can do here is use the factor tree. Right? We notice that, so with 4m plus 12 here, well, let's find something they both have in common. So in this case, the 4 and the 12, we can both take out a 2 because they're both even. We divide everything by 2, which gives us 4m divided by 2 is 2m again, and 12 divided by 2 is 6. Right? So this is very important here. When you divide an expression like this by a number, you have to make sure that every single term is divided by 2. Right? A common mistake I see is 4m plus 12, we have 2, and then 2m plus 12. Right? So make sure that this second term right here also gets divided. And now we notice that 2m plus 6 here, we can still take out a 2, right? Because 2 and 6 are both even. So which means that 2m plus 6 divided by 2 gets us m plus 3. Right? So what this means is that 4m plus 2 equals to 2. Right? So we got a 2, 2, and an m plus 3. So 4m plus 12 is 2 times m plus 3. Which means that it is just 4 times m plus 3. So just a quick reminder, normally we don't really write the multiplication sign when it comes to polynomials because it might get confusing with the variable x, right? So if you just see something like 4m plus 3 like this, it just means 4 times m plus 3. We notice that 4m plus 12 here, we can just take out a 4, right? Leaving us with an m plus 3 behind, right? Because 4m divided by 4 is m, 12 divided by 4 is 3. Right? So that's pretty much all there is to it. So when we factor polynomials in common factor, all we have to do is take out a factor that all of them have. Okay, so let's do some examples here. Right, first one, we have 6c plus 4c squared. So right away, we see that they're both even. So we can take out a 2 here, getting us 3c plus 2c squared. So now normally, we will be done. However, we also notice that right here, we have c and a c squared, which means that we can actually take a c out of the expression, right? If we take the c out, we are left with just 3 plus 2c. If that's allowed, it looks kind of cursed, but that is allowed. Not only can we factor out numbers or factors, we can also factor out the alphabets or the variables if they have a specific power. We have 2 times c times 3 plus 2c. And we can simplify that to just 2c, 3 plus 2c. Alright, and once again, just a quick check here. 6c plus c squared here. If we just take out the 2c, right? If we just take out a 2c or divide everything by 2c, we get 6c divided by 2c is 3. 4c squared divided by 2c is 2c. Okay? Next question here. So now we notice that quickly all of the terms here are divisible by 5. And we can also notice that all the terms here also divisible by z. We can take out a z out of each of them, right? So if we take out the 5z here, so if we divide the first term by 5z, we get z squared, or minus z squared. The second term, we divide that by 5z, we get minus 2z. And the last term, if we divide by 5z, we get a plus 1. And now, this is kind of cursed. Unfortunately, our first term in a polynomial can never be a negative. So in other words, the term with the highest power in a polynomial can never be negative. So what we can do is take out a negative 1. Right? So in this case, negative 1 is also a factor. Right? When we take out a negative 1, we have negative z squared times z, or negative z squared divided by negative 1 is just positive z squared. Negative or minus 2z divided by negative 1 is plus 2z. Plus 1 divided by negative 1 is minus 1. Which means that when we take out a negative sign, we get negative 5z times z squared plus 2z minus 1. Right? And that's our actual answer. Right? So technically, this is still correct, right? There's nothing wrong with this answer. But for the sake of convention and not making us mathematicians go insane, we make sure that our first term in a polynomial or the highest power remains positive. So we just take this negative sign out, and every other sign in the same polynomial gets flipped. Lastly, this one's a little complicated, but we notice that right here we have let's get a highlighter here. We got x squared, x cubed, x and x squared, y squared, and y squared. We notice that out of all the terms here, we can take out an x and a y. And not only that, with the numerical numbers, we can also take out a 4, right? All of them are divisible by 4. That's a lot. So all we are saying here is we can factor out a 4xy. Right? So let's check it out. When we factor out the 4xy, okay, we have that divided by 4xy. We get minus 3. X cubed divided by x is x squared. And then y divided by y is just y. Okay? This divided by 4xy minus a 5. X gets cancelled out. We got a single y left. And then this term divided by 4xy. We have a minus 4. X squared divided by x is x. Y squared divided by y is y. Means that when we factor everything out, or when we factor 4xy out, we get 4xy times negative 3x squared minus 5y minus 4xy. Okay, once again, we see something cursed here. This is a negative. We don't like it as our first term of the polynomial. So we take the negative sign out and consequently flip all the signs. So it becomes negative 4xy times x squared plus 5y plus 4xy. So that is all there is to it with common factors. So in a nutshell, we're looking at constants first. What can we factor out? Or what's the biggest number we can factor out? And after that, we look at all the variables or the alphabet. We can see that a lot of the terms have multiple powers of the same variable, which means that we can take out a few powers of the variable just so that it's smaller numbers to work with. Right, so the whole point of factoring is to go from those big numbers here to smaller numbers, right? Instead of like a 12, 20, and a 16, we have a 3, a 5, and a 4. Right, so factoring just makes our numbers smaller and easier to solve. With that being said, let's do some practice questions. So pause the video here and try to factor those polynomials. Alright, I hope you had a chance to pause the video and try those questions out. Alright, we'll just quickly get to it. So from here we have 8 and 12. We know both of them are divisible by 2, but we also know that they're both divisible by 4. So we can take out a 4. We also know that right here we have a d and d squared. We can also take out a d, which means that what you're left with is 8d squared times 4d, which is just 2d, and then 12d divided by 4d is 3. So the answer is 4d times 2d plus 3. Alright, so this one, not super complicated, luckily. Okay, moving on. So right here, we notice that all the numbers here are divisible by 6. And all the variables here are divisible by z. Or we can take out a single power of z out of all the variables. So we are essentially dividing everything, or factoring everything, by a 6z. Which means that the 8x cubed becomes a 3x squared, minus a 12z squared divided by 6z, which is just 2z. 6z divided by 6z is 1. Which means that our answer is just 6z times 3z squared minus 2z plus 1. Okay, last one here. So because all the numbers here ending in 5 or 0, we know that everything is divisible by 5. We also notice that we have a bunch of those variables here with some c's, some d's, but at the end of the day, all the variables, we can take out a single power of c and a single power of d, which means that our entire thing here, we can factor out a 5cd, right? So negative 20 divided by 5cd is 4c cubed, 30c cubed d squared divided by 5cd, 6c squared d, and then 25cd divided by 5cd, 5. Getting us 5cd times 4c cubed minus 6c squared d minus 5. Once again, we got a negative sign right here. So technically, we could have started off by dividing everything by negative 5cd, right? But we can do it later too. So I'm not skipping too many steps. So we take out a negative sign, so the first term is positive. Right? Doesn't matter if the second and third term are positive. It just ended up being positive, which is kind of nice too. Alright, so with that being said, let's hop over to some of the more complicated stuff. So right here, we're going to factor something like this. Right, so in this case, there's no common factors here. We cannot take out any x's, we cannot take out any of the constants. So what we have to do is the guess and check method or the crisscross method. Our goal is to set up a crisscross like this. The vertical, the first column here, those two numbers will multiply together to form this first term here. Right? So in this case, our crisscross will have to be x times x. Right? The only possible way for x squared to happen is just x times x. Those are the two factors of x squared. Alright, so now for the next column, C and D here, those two numbers have to multiply together to be the second term, or the third term here, the constant term. Which means that there are only two possibilities for this to happen. So it's either 1 and 6 or 2 and 3. Right? So those are the only two possibilities. It's either 1 times 6 or 2 times 3. And now you might be wondering, what's the point of this x? Right? This x is a quick mental way to help us illustrate the multiplication process. So our goal here is to get a 5 in the middle. To get to that point, we have to multiply this first factor by the second factor right here, and then we add it to the second factor times the first factor. A little complicated, but let's write it out. So with our first cross right here, let's do it in green here. We got x times 6, which is 6x. And now we add it to x times 1, which is 1x. That gets us 7x. Unfortunately, 7x is not the same as 5x, which means that this cross up there is a wrong guess. Alright, let's go guess and check. We're pretty much putting every single combination of the factors until one of them works. Alright, speaking of every single combination, here's the second combination. Right? We have x times 3, which is 3x, x times 2, which is 2x. Alright, and when we add them together, we get 5x, which conveniently is the middle number here. Which means that this guess right here, this configuration is then correct. Right? So once again, it's good to see here. We're just guessing and checking which one works. And now, with that being said, right, we'll have to write it out horizontally. Alright, which means that the answer to this question is x plus 2 times x plus 3. Right? So once again, when we figure out the cross, we have to write the answer horizontally. Alright, so there's a bunch of stuff happening here. First of all, when we set up our cross, the first column needs to multiply to our first term. Right? So those are the factors of the first. The second column right here needs to multiply to our second term right here. And once we get those, we should have a bunch of small crosses, bunch of possibilities. And then to check which one is correct, we cross multiply here. Right? So in the first case, we multiply the x and the 6 to get 6x, and then we multiply the 1 and the x to get just 1x, or x. And then we will add them up to see if this number right here is the same as the middle number. If it's not the same as the middle number, incorrect. If, in this case right here, we have 3x and then 2x, we get 5x right here, which is the same as the middle number, that is the correct answer. And when we get the correct answer, we write the answer horizontally, like this, to get x plus 2 and x plus 3. Okay, that was a lot. Okay, let's try something harder now. So, in this example, we will set up the cross again. Right? So, we want factors of 4h squared. There's a few possibilities. Okay? 4h squared. So the most obvious one is just h times 4h. Okay? So now with 9, there's also a few possibilities. We can just do 1 and 9. Okay, let's see if this works. So we'll do the cross multiplication here. Right? So 4h, or 9 times h is 9h, plus 4h plus 1, which is 4h, getting us 13h. Right, so unfortunately, 13h is not 20h, which means that this guess is incorrect, which is okay. we'll try another guess here. Okay, how about we flip it? How about a 9 and a 1? Okay, when we do the 9 and the 1, we'll do the cross multiply again. We get 36h, and then we have h times 1 to get just 1h, giving us 37h. Once again, still not 28. We'll keep trying. Alright, so this is why it's called a guess and check. Let's do like a wrong guesses cross here. So we try 1, 9, we try 9, 1. Okay, how about 2 and 2? Oh, sorry, not 2, 3 and 3. Okay, so we cross multiply here. 4h times 3 gets us 12h. And then h times 3 plus 3h. 15h. Still not quite. It's not 20. Another incorrect guess. Okay, we'll add that to the guess of shame. So now, this didn't work. How about let's try another factor for 4. Let's try 2h times 2h. So once again, we'll start with a 1 and a 9 here. Okay, right here, 2h times 1, we get 2h. And then 2h times 9, we get, oh, would you look at that? We get 18h. When we add it up, we get 20h. Ooh, okay, there it is. Right, this 20h matches the first term, which means that our answer, right, I should do green here. Our answer, we'll write it horizontally, is 2h plus 1 times 2h plus 9. Okay, so with that being said, let's do some practice questions here. So with all of those questions, let's try to factor with a crisscross method. We'll go over decomposition in a bit. Okay, hope you pause the video and have some time to practice. Alright, so the first one, we have x and x. That will always be the case. Okay, so let's start to guess and check. 1 and 12, what do we get? If we do 1 and 12 here, right, we have 1 plus 12, getting us 13x. Right, which is not 7x. Okay, next guess. Let's do 2 and 6. Okay, 2 and 6. 2 times x, not quite. Or 2. Alright, 2 times x is 2x. 6 times x, 6x. 2x plus 6x is 8x. Still not quite. Okay, next guess. 3 and 4. 3 times x, 3x. 4 times x, 4x. 3x plus 4x, 7x. That's the correct guess. Which means that we write it horizontally. Right? This gets us x plus 3 times x plus 4. Okay, cool. Okay, so with this question now, well, let's start off with just x and 4x. Okay, and now with negative 15 here, so remember, we have a negative sign right here. With negative 15 right here, we have to make sure that one of the factors is negative, right? So let's take negative 1 here, just as an example. So this will get us negative 4x plus 15x. Gets us positive 9x. Right, not quite 4. So this is not the right guess. We can try, how about 1 times negative 15? We get negative 15x plus 4x gets us negative 9x. Still not 4x. Okay? No worries, let's keep guessing. Okay, how about 3 and 5? Right, so let's have a negative 3 first. So we have negative 3 times 4x is negative 12x. And we add that to 5x, getting us negative 7x. Okay, so that's not quite. We will try negatives, but as you can probably see now, if the number we get isn't equal, doesn't matter where the negative sign is. Right, so instead of a negative 7x, we get a positive 7x, which is still not accurate. Right, so if the negative sign doesn't work, you don't need to try all of them. Okay, so the x and the 4x didn't work. Let's try 2x then. Right, 2x and 2x. Okay, 1 and 15. Just right off the bat, it's probably not going to work. That's a huge number, right? But just double check. 2x times 15 is 30x minus 2x, right? That's going to get us 28x. So that's not the correct guess. Okay, let's move to 3 times 5. Right, let's do negative here first. So this gets us 2x times 5 is 10x minus 2x times 3, or negative 3 is 6x. So, well, would you look at that? We get a 4x here. Okay, so that is a right guess. Which means that So again, we write our answer like this, which means that this question factors to 2x minus 3 times 2x plus 5. Right, just like that. Okay, next one, 15g squared. Okay, so at this point, we could start off with 15g and 15g, but we notice that we're working with a 2 here, right? Our last term is a 2, and we have to somehow get a 1 for the middle one. So right off the bat, we kind of logic it out that 1 and 15 probably isn't the factors that we use. Right? Because no matter what, it's 2 times 15 equals 30. So that's not going to work. The number is too big. So we can cut corners and start guessing by 3 times 5, or 3g times 5g. All right, so now let's take the factors of 2. Let's do 1 and a 2. All right, so because it's a negative 2, we want to make sure one of the factors is negative, so we pick negative 1 here. So we get 3g times 2, we get 6. And then we get 5g times the negative 1 is minus 5g. Oh, perfect. Well, we're close. Right, when we add those up, we get positive g, which means that our factors are correct, just the wrong negative sign. So we just have to move this negative sign down to here. Then we get minus 6g plus positive 5g to get negative g, which is the number we want in the middle. Right, so once again, rewrite everything sideways to get 3g plus 1 times 5g minus 2. Okay, last one here. 14r squared and then a 3. Once again, chances are, if we start off our guess like this, it's probably not going to work. Those are huge numbers to work with. It's either going to be 11, or it's either going to be something with 14 here, or we have a 14 times 3, which gets us 52. It's going to be nowhere near 13. So we can start off our guess by an r, a 2r and a 7r. Now all we have to do is to get check out a 3. So we can try 1 and 3 first. Right? So with 1 and 3, we get, when you cross multiply, we get 2r times 3, which is 6r, and then plus 7r gets us positive 13. Oh, just realized, why is there a y here? But that's my bad. Okay. So now, in this case, we notice that we actually are really close, right? We guessed 13r, but it's positive. But we want a negative r in the middle somehow. So what we can do instead is notice that there's also another way to get a positive 3. If we multiply two negative numbers together, we also get a positive 3. Which means that we can try something like this, where you have negative 1 and negative 3, right? Because at the end of the day, this column right here needs to multiply to this number. Negative 1 times negative 3 still gets us positive 3. But when we cross multiply, we have minus 6r minus 7r. Right? Gets us negative 13r. Right? Which means that when we write out the answer horizontally, we get 2r minus 1 times 7r minus 3. There we go. Very cool. Okay, so now with that being said, let's go over the decomposition method. We'll take this question here, 3s squared minus 13s minus 3. So what we do here is multiply the first term with the last term, just the constants. So in this case, you have 3 times negative 10, getting us negative 30. And then after that, we'll list out every single factor we can think of for negative 30. So we can have 1 times negative 30, negative 1 times 30. We have 2 times negative 15, negative 2 times 15. 3, negative 10, negative 3, 10, and then 5, negative 6, negative 5, 6. Right, so those are all the factors of 30. Okay, and then from there, we can add all those factors together. All right, when we add all those factors, so in the first case, we have 1 plus negative 30, which is negative 29. And then for the second one, we have negative 1. Right? Negative 1 plus 30, we get positive 29. Okay, then we go down the list. So 2 minus 15 is negative 13. Positive 13, negative 7, positive 7, negative 1, positive 1. And we notice that in the end, we want one of the pairs that corresponds to the middle one. Okay, so we want one of the factor pairs to correspond to the middle term. And we notice that right here, 2 plus negative 15 gets us negative 13, which is exactly what we want. Right? So let's highlight this row right here, a super important row. So this is exactly what we want, which means that 3s squared, we can break that down into plus 2s and minus 15s. Right? So we have a 2 and then minus 15. We can break down the negative 13s into plus 2s and minus 15s. Right? Minus 10. Alright, but unfortunately we're not done yet. Right? So let's just like move this here so we have more space. We can use what we learned earlier with the whole factoring polynomials as common factors. Right? We noticed that the first term here, right, the first two terms, we can take out an s, right, because we have an x squared and an s by itself. And the second term here, we can take out a negative 5, right, because we got a 15 or negative 15 and a negative 10, or minus 15 minus 10. So when we take all of them out, right, we get something like, so we can take out the s from the first two terms, we got 3s plus 2 left over. And then we take out a minus 5 or negative 5. We get a positive 3s plus a 2. Right? Because negative 15s divided by negative 5 is 3s. And then negative 10 divided by negative 5 is 2. And we notice that right here, we can now factor out the 3s plus 2. Right? If we factor out the 3s plus 2, we are left with s minus 5. All right, and that right there is our answer. So as you can see here, this is the exact same answer as we would have gotten with the guess and check. Right? And just to quickly show y'all, right, we have, again, 3s. So the only factors is s and the 3s. And now let's do some guessing and checking. So we can do a 2 and a 5 here. If we do a negative 2 here, we get 3s times 2, which is 6s. S times 5, which is 5s, gets us negative s, which is not the right guess. So we can try, let's say, flipping around. Right? So once again, s times 2 is 2s. 3s times 5 is negative 5s, which gets us negative 13s. Right? So with the guess and check method, we find that that's the right answer. We write the answer horizontally to get s minus 5 and then 3s plus 2. Right? So as you can see, with the guess and check method, we got the exact same answer. Whoops, not the ruler. Exact same answer as we would have done with the decomposition method. Right? So use whatever method is easier for you. Personally, I'm a bigger fan of the guess and check because it's just faster. Right? I feel like guess and check is faster to learn, or way harder to learn, but once you understand it, it makes it a lot faster in decomposition. Right? So let's just erase all of this and pause the video here again with the same questions. Now let's try the decomposition method and see what you come up with. Alright, let's go over the answers now with decomposition method. So right here we have 1 times the 12. Right? So when we decompose it, we got 12. So to list all the factors, we got 1, 12, 2, 6. Okay, so now those are the factors of 12. And then when we sum it up, we have 13, 8, and 7. So which means that we can decompose the 7x into 3x and a 4x. Okay, so it becomes x squared plus 3x plus 4x plus 12. All right, and then from there, we can factor out an x, factor out a 4. So we can have x times x plus 3 plus 4 times x plus 3, which gets us x plus 3 times x plus 4. All right, there we go. That's decomposition method. Time to shine. Okay, so next one here, we have the first term to the second term getting us negative 60. Oh, not positive, negative 60 right here. Okay, so once again, we'll list out all the factors, except it'll probably take way too long. So, all right, so next we'll list out all the factors. So we have the whole 1 times negative 60, negative 1 times 60, right, etc. And eventually, you'll get to negative 6 times 10, right, which gets us positive 4, which is what we want. Right? So with that, we will decompose this into 4x squared plus, or not plus here now, minus 6x plus 10x minus 15. Okay, first term, we can take out a 2x. Second term, we're going to take out a 5. Okay, so take out a 2x, you get 2x minus 3. Take out a 5, we get a 2x minus 3, which means that our answer is 2x minus 3 times 2x plus 5. Next, 15 times negative 2 to get negative 30 here. Okay, so once again, when we list out all the factors of negative 30, so things like 1, negative 30, negative 130, eventually we will get to negative 6 and 5. And as we know, negative 6 plus 5 is negative 1, which means that this is what we want. So we decompose this to minus 6g plus 5g minus 2. We can take out a 3g here, and 5g minus 2 can leave it as it is because nothing to factor out. So we take out a 3g, leaving out as 5g minus 2. Very convenient. We can put a bracket here just to differentiate it. So we have 5g minus 2 times 3g plus 1. Okay, last up, 14 times 3. All right, and you might have noticed here that we could just do 1 times 42, 2 times 24, etc. But we notice that our sum right here, not ruler again, our sum right here needs to be a negative, which means that instead of positive 1 and 42, it's probably going to be negative 1 times negative 42, because they still multiply to 42, except when you add them up, you get a negative number. Okay, so again, you just go down the factors of, no, not 24, 21, the factors of 42 until we reach negative 6 times negative 7. When we add it up, we get negative 13. Okay, so we decompose the negative 13r, or minus 13r, to minus 6r minus 7r plus 3. Okay, we divide everything by 2r here. Alright, and from the back, we can take out a negative 1. We're giving us 2r times 7r minus 3 minus 7r minus 3. Okay? This is a minus 3 here because we take out the negative 1 from a plus. So it becomes minus 3. So lastly, we get 7r minus 3 times 2r minus 1. Alright, so as you can see here, they're the exact same answers. The only difference is the method on how we get to it. So realistically, doesn't matter which one you use, you always get to the same answer. And yeah, huge thank you to you if you sat through this entire lesson here. That was a pretty big doozy, but we did cover pretty much 2.5 chapters. Alright, so with that being said, keep practicing and stay hydrated.